All right, starting on page 2 of the notes, a balanced chemical equation is an equation in which each side has the same number and type of atoms. So, for example, in this equation, if I have hydrogen and oxygen reacting together to form H2O, which is a real compound, hydrogen has to have a 2 on it because it's diatomic, and oxygen also has to have a 2 on it because it's diatomic. But that doesn't mean that the 2 and the 2 will automatically be brought into the compound that they form together. So here we use coefficients in the beginning to show how many of each of those compounds or substances we would need. So to make sure that we have our terminology correct, first of all, subscripts are the little numbers. These tell you how many atoms of each element are in a compound. So we've been using subscripts this whole time. The little numbers are these little guys. The subscripts should always be written at the bottom. Some of you started writing them at the top for some reason. So just make sure that you write the subscript as like a small number down below. And then the coefficient, just like in algebra, is going to be the number in front, which provides the lowest whole number ratio of the amounts of all reactants and products. So as a reminder, your reactants are your starting substances. They're doing the reacting, and then products are things that are formed. So when we are balancing a chemical equation, the first step is to write a skeleton equation using the correct formulas for all reactants and products. Highlight correct formulas. This is where your nomenclature comes in, where you need to make sure that you have the correct formula for every single thing that you're putting into your equation. So for example, if I look down here and I have sodium hydroxide reacting with calcium bromide, if you start off with the wrong formulas for either one of those things, then your products might be messed up, their balancing is going to be messed up, it's going to be impossible to balance your equation. So take an extra second or two to make sure that your formulas are actually correct. And then you're going to count the number of atoms of each element in the reactants and products separately. So I'm going to say right here, we're going to write what we're going to call an R and P chart. And I'll show you how to do that. And then I'm going to highlight again, polyatomics that are unchanged on both sides of the equation will count as a single unit. And then you'll change the coefficients only to make the number of atoms of each element equal on both sides of the equations. You will never change the subscripts, because if you change the subscript, you're changing what the formula is, and if you have the correct formulas to begin with, you don't want to change those. So the subscripts will not change as long as you wrote them correctly in the first place. If you have a coefficient on something that has a subscript, you will multiply it out, basically distribute that to everything that's in that compound. And then this part isn't actually a rule, but it's just kind of more of a tip, is to leave hydrogen and oxygen until last when you're balancing, because these two elements often occur, it says more than twice, I think I meant more than once in the equation. Then at the very end, you're going to double check that everything is actually balanced, and make sure that the coefficients are in the lowest possible ratio. So you're going to reduce them if you're able to. So just to practice, on this side of the equation, we call these our reactants. And on this side, we call these our products. And what separates them is this arrow. So I'm going to have an arrow in between them. So underneath the arrow, I like to have students give themselves a column that you're going to write in. And that's where we will list all of our reactants and products. Because of the law of conservation of mass, the reactants and products are going to be the same things. You just have to be careful about how you list it. So first, I have zinc. I'm going to list that as my atom, so Zn. And then if I keep reading, the next thing I run into is hydrogen. So I'm going to list hydrogen as well. And then after hydrogen, I run into sulfur, but you'll notice that this sulfur is part of SO4, which is sulfate, and I have sulfate on my reactant side and on my product side unchanged. So because this is sulfate and this is also sulfate, I can take a shortcut and list SO4 as one of the things that are in my reaction. So this is what I meant by polyatomics unchanged on both sides count as a single unit. We can count this as a single unit since it's a polyatomic, and it's the same thing on both sides. Sometimes what you'll see is you'll have like sulfate on one side and sulfite on the other. If your subscript changes, that's not the same thing, and you have to list out the elements individually. So in this little part, when you're counting your reactants and products, I'm talking about the chart itself, don't use a subscript. Unless it's a polyatomic. So you'll notice, even though hydrogen is diatomic and it lists as H2, I'm not going to put the 2 here because it's not going to always show up as diatomic on both sides, since it could be part of a compound on one side or the other. So then on either side of this, what you're going to do is just count how many times that unit shows up. So if I look at my reactant side, zinc doesn't have a subscript. The little S next to that stands for what? Solid. Good. So this is just telling you the state of matter, but it has nothing to do with the actual balancing. So zinc, there's just one of them. So on my reactant side, I have one atom of zinc. And then on my reactant side, I have 2 atoms of hydrogen, and I know that because there's a little subscript of 2 next to hydrogen, so I'll mark that as well. And then also on my reactant side, I have one, we'll say, unit of SO4 or sulfate. So I have one sulfate here. Because that 4 that's part of this is part of sulfate's name. That doesn't tell me I have 4 of them. That's telling me I have one total sulfate. If I had multiple sulfates, remember, it would have to be in parentheses and there would be a subscript on the outside. And then on my product side, how many zinc atoms do I have? Just one. On my product side, how many hydrogen atoms do I have? And then on my product side, how many sulfate units do I have? Just one. So what we mean by balanced is that I have 1 and 1, 2 and 2, and 1 and 1. Each of them match up perfectly, so this is already balanced. But what I wanted you to get the feel for is that this down here, this R and P chart, is just a tally of how many of each. Meaning, if you want to change how many there are in your reaction, you need to use a coefficient. You can't change it at the bottom. This will change as a result of what you do in the coefficients. So in this case, since my equation is already balanced, and there are lines here, anytime there's a line, you have to fill it in with something. It's not going to be 0, because if you had 0, that means it's not part of the equation. So we're going to fill it in with 1s all the way across. So that just means I'm not changing it. The coefficient is 1. But sometimes if there aren't lines in front of it, so if it's something that you're writing yourself, for example, like here, if I have 2H2 and then just plus O2, it's kind of implied that there's a little invisible one there. So we try to not use ones if we don't have to. But if there are blanks, just to not leave the blanks empty, you're going to fill it in with 1s as placeholders, but that will be your last step once everything is balanced. Good, so the first one was just about learning how to count them. Then the second one, we have names here, so we need to write the formulas for each of these. So starting with sodium hydroxide, if you are not fully comfortable with nomenclature yet, there is nothing wrong with like making marks out to the side to make sure that you're crisscrossing effectively and not making silly mistakes there. So sodium hydroxide is going to be the combination of sodium that has a +1 charge, and then hydroxide is one of my polyatomics. What's that? Perfect. OH with a -1 charge. So when I crisscross it, it would be a 1 and a 1, but we don't write the subscript of 1. So the formula for sodium hydroxide is just NaOH. And then the next one is calcium bromide. So calcium is Ca, and it has a +2 charge. Bromide comes from the nonmetal bromine, so that would just be Br with a -1 charge. So when you crisscross it, it becomes CaBr2. And then just as like a little preview, because we'll talk about double replacement reactions later on, that's what this one is. if you have an ionic compound bonding with another ionic compound where you have two things and two things, you have a cation, so sodium was my cation, it was listed first. Hydroxide was my anion, it was listed second. Here I have calcium and bromine. Calcium was my cation, it was listed first. Bromine is my anion, it was listed second. What's going to happen every time that two compounds like this get together is they are going to trade partners. So we call that a double replacement reaction, where in your products, you're always going to have the positive one bonded with the other negative one, and then this positive one bonded with the other negative one. So they're trading partners. It's always going to go positive, negative, positive, negative. You won't have the two negatives together. You won't have the two positives together. And then if we look, that's actually what's happening. So I have sodium is going to be partnered with bromine. That's how I got sodium bromide. And then calcium is going to be partnered with hydroxide, and it becomes calcium hydroxide. And it goes in that order because your cation is always listed first. So calcium hydroxide is going to be calcium with a +2 charge. Hydroxide has a -1 charge, And then when you crisscross it, the 1 comes down and the 2 comes down, but I want to put a subscript of 2 on hydroxide. What do I need to do differently? Perfect. Parentheses, because I'm showing I have 2 hydroxides and not just 2 hydrogens. So I'm going to write Ca and then OH2. I don't write the 1 from hydroxide. And then I'll do the last work over here. I have sodium +1 charge and bromine with a -1 charge. Some of you are at the point now where you can do that in your head. That's totally fine. You don't have to show your crisscrossing work. But I do want to see your R and P charts. So NaBr for that one. Good? Okay, then we're going to separate, so where the arrow is, you're going to draw your little column so that you can list out your reactants and products. So if I just read this like a sentence, I start here, the first thing I run into is sodium. And then the next element that I run into is oxygen, but oxygen is part of hydroxide here, and it's also part of hydroxide there. So I have hydroxide unchanged on both sides of the equation. I'm going to list this as hydroxide and keep them together. And then I have calcium, and then I have bromine. So then just like I did in the previous example, I'm going to count or tally how many I have of each thing. So on my reactant side, I have 1 sodium. How many hydroxides? 1. How many calciums? And how many bromines? 2. On my product side, I have just 1 sodium. There's no subscript there. I have 2 hydroxides, so that subscript of 2 tells me I have 2 of that. I have 1 calcium, so since calcium is not in the parentheses with hydroxide, that 2 does not apply to the calcium as well. So I only have 1 calcium, and then bromine, I just have 1 as well. Bromine is diatomic, but that only applies when it is on its own. So if this reaction were including bromine as like a standalone reactant or product, so like in this case, for example, hydrogen is diatomic because it's just hydrogen. Bromine would be diatomic because it would be just bromine here, but if it's part of a compound, the fact that it's diatomic does not mean that there's going to be 2 of them. So like NaBr, we got that formula by crisscrossing the charges, so it does not have a 2 on here. Diatomic only matters when it is on its own. Good question. So then my sodiums are both balanced. I have 1 on one side, 1 on the other side. My hydroxides are not balanced. I have 2 hydroxides on my product side and only 1 on my reactant side. So I need to make this number equal 2, but remember that this is just a tally of how many there are. So in order to change this number, I need to use a coefficient. So where could I put a coefficient that would change the count of hydroxides on my reactant side? A 2 before... Okay, so before the hydroxide, make sure that you're understanding it has to go before the whole compound. So I can't change hydroxide here without also changing sodium, even though maybe that's not my goal. I have to put the 2 in front of the whole thing. So then the 2 affects both things that it's behind, and then it gets distributed to both of them. So the 2 goes to the sodium, and the 2 goes to the hydroxide. So now I have 2 sodium atoms on my reactant side, and I have 2 hydroxide units on my reactant side. So the 2 applies to both things that it's in front of. So now I messed up my sodium that was already balanced. I didn't want to change that, but I didn't have a choice because that's where hydroxide was. So now I have to go back and balance my sodium. There are 2 on this side now, so I want 2 on my product side. So I'm going to use a coefficient of 2 in front of the compound that contains sodium on the product side. So that would be here. So then if I put a 2 right there, again, the 2 distributes, so it applies to the sodium and it applies to the bromine. So I have 2 times 1 sodium gives me 2 sodiums, and 2 times 1 bromine gives me 2 bromines. So you see it ends up working out. Yes. We made up the 2 as a coefficient because that's what would help us to achieve the same number on both sides. So there's a little bit of guess and check that goes into this. Some students really like it because it's like a puzzle, and some students really don't for that same reason. So once you're balanced, once everything is equal, so I have 2 sodiums, 2 sodiums, 2 hydroxides, 2 hydroxides, 1 calcium, and 2 bromines, 2 bromines. Everything is balanced. I only had to put coefficients in 2 places, so your last step is in the ones that you didn't have to put a coefficient, you'll fill it in with the coefficient of 1 just to show that it's going to be multiplied by 1. So 1s are your last step. Yes. If you're writing it yourself, normally on something like this, I wouldn't require it, but if the blanks are provided for you, then yes. And then the other thing that you're going to see with this is like on your test, for example, we would give you answer choices like A, B, C, D, and then the way that you would see the coefficients, or you'd balance it, and it would be like 1, 2, 3, 4, and then 2, 1, 2, 2, and then 2, 1, 1, 2, and then 2, 1, 1, 1, something like that. And you would have to pick the right answer choice that would fill in the blanks in order to balance it. And so if you don't have 1s, then it doesn't give you the right number of blanks. So the 1s are almost like placeholders. Does that make sense? Okay.
So we added the 2 to make it balanced, but it was already balanced.
It wasn't already balanced. We used a coefficient of 2 right here and a coefficient of 2 right here so that it would multiply by the compounds that were behind it and then cause the number of atoms on each side to be balanced. Let's try another example and see if that helps it click. So this one, I have iron 3 chloride and sodium hydroxide reacting together to form iron 3 hydroxide and sodium chloride. So underneath it, underneath the arrow, we're going to give ourselves a little column and then list each of the things that appear in our reaction. So the first thing I run into is iron. So I'll list iron. Then I list what? Chlorine, just as Cl. Do I keep the 3 with it? No. Alright, and then what about this one? I'll list sodium, and then perfect. So start recognizing your polyatomics. If it's unchanged on both sides, count it as one thing. It makes it a lot easier. You can still get to the right answer if you like counted oxygen as one thing and hydrogen separately, but it does make it a lot easier often to keep it together. So then if I count how many iron atoms I have on my reactant side, I would have 1 iron. How many chlorine atoms? 3. How many sodium atoms? And how many hydroxide units? 1. Okay, and then on my product side, I have 1 iron. How many chlorines? Yeah, 1. And then how many sodiums? And how many hydroxides? 3. Okay, so you see how this is shown differently, where that 3 tells me I have 3 of these things. So is this equation already balanced? No. So then I usually just start at the top and I go in order. You can jump around however it makes sense to you, but I just go down the list. So my irons are already balanced. Then I go to chlorine, and chlorine is not balanced. I have 3 chlorine atoms on my reactant side. I only have 1 on my product side, so I'm going to use a coefficient of what, where? A 3 in front of what? If I use a 3 in front of FeCl, that would give me 3 iron and 9 chlorines. Is that what we want?
No.
Perfect. Okay, so a 3 in front of NaCl on the product side. So if I put a 3 here, there'll be a lot of times also where you put in coefficients, it starts to work, and then you have to change your coefficients. That's okay. You can cross it out. You can erase it. So don't feel, I guess, scared to take a risk and see how it works out. So I have 3 times 1 sodium. That would give me how many sodiums on my reactant, or my product side? So I'll change that to 3. Even though they were already balanced, now I just messed it up, but that's okay because I need to fix my chlorines. So 3 times 1 chlorine is 3 chlorines. So now my chlorines are balanced. So that's good there. My irons are still good, my chlorines are good. My sodiums got messed up because of what I just did. So I want to add more, I want to multiply more on the reactant side. So I'm going to put a coefficient of 3 in front of what compound? Perfect. And then you'll notice that fixes both things. So I have 3 times 1 sodium gives me 3 sodiums, and 3 times 1 hydroxide gives me 3 hydroxides. So I have 1 and 1, 3 and 3, 3 and 3, 3 and 3. Are we all balanced? Yes? Okay, so then our last step is to put 1s in the blanks where you need them. So notice that we're not doing any math down here. This is just counting up how many atoms we have. If we want to change something, we change it in the coefficients. Good? Alright, last one on this page, and then things will get a little bit trickier. So there's a rule that says the number of elements of the same kind get added together when they are in different compounds. So let's take a look at this example. It says carbon disulfide reacts with oxygen to produce carbon dioxide and sulfur dioxide. So again, take an extra second to make sure that you have the correct compounds before you start trying to balance. So carbon disulfide tells me I have how many carbons? Okay, and disulfide is S2. So this one's named differently because it's a covalent compound. And then it reacts with oxygen. So reacts with oxygen means it's being added to oxygen. It's not going to react if it's not added to it. So the formula for oxygen is O2, and we put the 2 on it because oxygen is diatomic. So here is where the fact that oxygen is diatomic matters. And then it produces carbon dioxide, so CO2, plus sulfur dioxide, which is, yes, SO2. So then underneath your arrow, you're going to list all of the things that show up in your reaction. So the first thing I have is carbon. The next thing I have is sulfur. And then the third thing I have is oxygen. There are no polyatomic ions in this one, so we could just go straight count them. So I have 1 carbon on my reactant side, 2 sulfur atoms on my reactant side, and 2 oxygen atoms on my reactant side. On my product side, I have 1 carbon atom, I have 1 sulfur atom, and I have 1, 2, 3, 4 oxygen atoms. So you see that oxygen is in 2 different places, but when we're counting how many oxygens total are on my product side, I add them all together, so there are 4. So then my carbons are already balanced. My sulfurs are not balanced. I have 2 on my reactant side and only 1 on my product side. So where am I going to put a coefficient, and what coefficient will help me? I think I heard something. Okay, so a 2 in front of SO2, so a coefficient of 2 right here. 2 times 1 sulfur gives me 2 sulfurs on this side. And then here's where you have to be careful about making sure you're keeping up correctly, and this is why it matters that down here, You're not doing any math. This is just a tally, so you have to pay attention to the coefficients themselves. 2 times 2 oxygens gives me how many oxygens? 4 from SO2. Plus, I add to that the 2 oxygens that I already had from carbon dioxide, so that's 2 plus 4 gives me a total of how many oxygens on my product side? 6. So notice that I didn't just multiply both of these values by 2. If you do that, it's going to give you the wrong count. So then if you get confused by having little numbers there, scratch it out so you don't get confused. So now you have to count them separately every time. So now I have 1 and 1, 2 and 2, and then I have 2 and 6. So what coefficient will help me? Perfect. A 3 in front of O2. So 3 times 2 oxygens gives me 6 oxygens. And then everyone is balanced. So in any of the blanks where we didn't put coefficients before, it's just going to be a coefficient of 1.